Now we can do one more thing with the slope coefficient, and that is to estimate the elasticity between the two variables. Here in our example, it will be price of crude oil per barrel and price of gasoline per gallon. Okay? Or it could be price of the product and demand. Usually in economic terms, elasticity of demand is the sensitivity of the demand to price. Okay? If the demand is very sensitive, so then elasticity will be greater than 1, otherwise it will be less than 1. So that is, in general terms, elasticity is defined as between two variables, percentage of change in y divided by percentage of change in x. So if x goes up by 10% and if y goes up by 10% also, then this ratio will be equal to 1. If x changes by 10% and y changes by 5%, change, it could be positive change or negative change. We are talking about absolute change here. Then it will be half. Okay. If x changes by 10%, y changes by 20%. Okay, either positive or negative. Absolute change, 20%. So that will be elasticity of 2. So which means the variable is highly elastic with respect to x. Okay, so demand is highly elastic with respect to price. So less than 1 means it is not. Okay, there is not a whole lot of thing going on between x and y. But if it is greater than 1, it is very sensitive to changes in x. And that elasticity can be computed using this formula. Once you know the value of b sub 0 and b sub 1, we can compute the elasticity using this formula. So let's compute the elasticity for our example now. So let's gather the information that we need. B sub 0 first. Okay, so b sub 0, we'll get it from here. So now we copy that down, then we'll get b sub 1. Okay. Now let's suppose that we want the elasticity for when x is equal to a particular value, and we'll use the same number that the textbook uses. So then this is the formula. So we need b sub 1 times x. So that's the numerator. And then the denominator is b sub 0 plus b sub 1 times x. Okay, so now we take the numerator, divide by the denominator, and what we get is the elasticity. And now you see the elasticity is less than 1. So that means it's not that sensitive. Okay, but the problem here is if x changes, elasticity also will change. That's not intuitive because you want elasticity to remain the same irrespective of what x is. So the problem is because if you look at the plot, and there is a lot more variability towards the end and a lot less towards the beginning. So this is one of the reasons why these problems arise. So when such problems come up, what we can do is we can do some transformations. We talked about transformations earlier in chapter 3 and 2 as well. So let's do a log transformation. Okay, and then we can compute the elasticity from that log transformation. So if you want constant elasticity for changing values of x, the natural log transformation for both x and y will help us. So you transform y into ln y and transform x into ln x. Okay. Now you run the regression, and the regression will come out to be something like this: b sub 0. Now this is a different b sub 0 with the after log transformation, and then b sub 1 times ln x. Now to convert it back to original y, we have to apply the exp transformation. When we do that, you get y e to the power of b sub 0 times x to the power of b sub 1. Okay, so then the b sub 1, you see whatever percentage change in y, B sub 1 tells us how much y will change, how much x will, for a percentage change in x, what will be the change in y is given by as a percentage by B sub 1. So this is your constant elasticity. So if you find the slope after the transformation, then the slope gives us the constant elasticity. So let's look at that in Excel. Okay. So first thing to do is to do the transformation. So let's go to the data. So we want ln of unleaded. So you go ln, the unleaded value, and then ln of L1 crude. So if you copy that there, then that would be the log transformation. So now copy that all the way down. Okay, now let's use data analysis. Okay, regression. Okay, so the old information is still there. Let's clear them. Okay, now the y range. Okay, now the y range is going to be our ln unleaded. Okay, now x range is ln crude. Okay, now labels. Now let's put the output right there. Okay, so now the elasticity is B sub 1. So the equation for the transformed variable is right there. Okay, so elasticity is just that. This tells us how much y will change for if x changes by 1 unit. So for 1%, then we take that and divide by 100, and you express that as a percentage